Now let us find standard deviation, range, min, max, and the variance in R. So this is the same sample data set what we have used in the Excel sheet to find out the variance and the standard deviation. So what I will do is I'll just take this sample set again and then we can work on this data. So what I have written is x is equal to c. So I have created a vector for this sample data. So I'll execute this. And now what we can find is we can find the range. For that we can use the command range, and inside this we can pass x, and if I execute this I will be able to find the range. See, the range is 1 and 6. Okay, and if you want to find the minimum value, you can use min, and inside that again pass x. Now here if I execute this, the minimum value is 1. Similarly, for maximum we can achieve that by max, and inside this I am passing x, and if I execute this, the max value is 6. So for finding the variance, what we can do is VAR, and inside this we can pass x and just do a control enter. So the variance is 4. And for the standard deviation SD, and inside that I have passed x, and if I execute this, the standard deviation is 2. So here in this case it is taking the sample data for a variance and for the standard deviation. So this is the example, the basic example in which we have seen how to find the range, how to find min, how to find max, the variance and standard deviation. Now let us talk about an important concept called as outlier. Now let us see an example of an outlier. So let us say if you have certain values, let's say a sample set of data, for example like 1, okay, 1, 2, 4, 8, 10, and then 100. Okay, so this is your sample data set what I have given you. So it consists of 1, 2, here 4, 8, 10 and 100. So if you, this is a very small sample data set for your understanding. So if you look at this data set, what is the unusual thing do you observe? What comes in your mind? So if you observe this data set over here, you see that these values are like 1, 2, 4, 8, 10 is in a certain range, and then suddenly you see a value called as 100. Okay, so these kind of values, the unusual values in a sample data set, these are called as the outliers. So let us say if this is something, if we want to plot it in a scatter plot maybe, so this is your x-axis and this would be your y-axis, and these are certain data points over here. Okay, this is having certain variable x and this is having certain variable called as y, and let us consider that we are plotting a scatter plot based on certain values. And while plotting the values, if you observe this behavior, okay, and these are the certain data points I would say based on our sample data set. Okay, let's say these are the different values what you have, and here over here you see a certain value. So if you see this, the distribution of the data is majorly based in this portion, but you see a point over here which is far away from this area, which is far away from this area where the maximum points are located. You term this as an outlier because it is far away from your maximum data points. Okay, let us take another example. So in this case, you saw that it is far away. The value of this data point is extremely high. It means this is the value of x is too high and the value of y is also too high. And the major data points are concentrated over this area. Now let me take another example. Again, I will draw x and y axis over here. So this is our y-axis and this is our x-axis. Again, what I'll do is I'll draw certain patterns over here. These are the data points where our data distribution is over here. Okay. Okay. So this is the maximum area where our data resides over here, and we can, if we see a very minimal value over here somewhere, then also we can term this as an outlier, because again the maximum data points, if you see the distribution, the pattern of your data, the data is present over here, but there are certain data which is present in the, which has an extremely low value. So either in both the cases, this one is having an extremely high value and this is having an extremely low value, you can term it as an outlier. So these are called as outliers. So you can relate it with the other examples also. Let's say if you take an example of social media usage, okay? So with a certain age group, let's say from 16 to maybe from, let's say from 16 to let's say 45. This is the age group where you would see maximum, data points being present. The distribution of the scatter plot would have maximum points in this range. But if you see a certain value wherein the value is like the age group what you observed in your data is around, let's say 95, then definitely you can term this as an outlier. Or else you can if you find extremely low value, for example let's say 6, somewhere around in the range of 6, then again you can term this as an outlier. Okay, so these are basically the unusual values which is present in your data set. So what is the cause of these kind of data set? One reason is the source of the data, the source of the data as in human intervention. The human error is one of the causes that may have this outlier being present in your data set. And for example, let's say if you are opening a certain account, okay, so by default there are certain values in the drop down. Let's say in the gender it is male, okay, in the age group it is, let's say 18. So if this is the default one, then there is a high possibility that people do tend to keep these things remain constant and they register in the social media account. Just giving an example. So then you might observe these kind of data in a very high range. Okay, so now we talked about the outliers. Now let us talk about the different types of data. So while doing your data analysis, you will definitely find different types of data, and you will definitely work on different types of data. So the first one, what we will talk about is the quantitative data. So this data consists of numeric data. This quantitative data consists of numeric data. You can say that the data which you have received contains all numbers, then you can term it as a quantitative data. Second is the qualitative data. It majorly contains a string data type. For example, if you talk about the quality of a fabric, it may be rough, it may be smooth, slightly rough, or slightly smooth. So these are examples of qualitative data. And then you have categorical data. So categorical data are represented by grouping variables, for example gender, male, female. So this is the best example of categorical data, and your gender is a grouping variable. The next part is the nominal data. Once again, this type of data is categorical and non-numeric, typically strings, and they cannot be arranged or sorted in any order. Okay, then the next part of data is the ordinal data. So this is a categorical data which can be arranged in some order, and it takes a string or a numeric values both.